Okay, so now we have all the force, all the unknowns. So let's write the final form and then solve the problem. This is not a good circle, but it is enough to explain. So we have the weight, we have the normal force, we have the frictional force, we have the force here with two components, and then acceleration. Okay, that's all. And then rotation in this manner, alpha. Okay, then the equations that we have is these equations. We will use this part. And then since in this case we don't have a, so the point G moves in a straight line. Therefore, we don't have no t and then n directions. T is same as x and then n is same as y. Okay, that's the issue, that we will not use t and then n directions. Okay, so let's start one by one. The first is that the forces acting in x direction is resulting in an acceleration in x direction. So we have negative f of f, we have the components of f, which is 30 degrees, so that will be plus f times cosine 30 degrees, that will be equal to mag in x direction. So we have one equation and then 1, 2, 3 unknowns, which is not a good sign. So 1 unknown, 3 unknown, and 2 unknown, and 3 unknown. Next is that f of y is m of g of y, and this term is 0. So that means that the n minus w plus f sine 30 degrees, 0. So we have one equation and one unknown. That is the n. F has been defined before. So we have two equations and then 4 unknowns. We need one more equation. M of g is equal to ig into alpha. So let's come back to our problem again. So we take the moments about point G. So we have this force F with an arm, and then we have frictional force with an arm. Okay, and then it will be that F times the arm of F is the radius, which is 0.3. Arm of F is the second radius, which is 0.5. And this one rotates this way, and that one rotates this way. This is, so counterclockwise will be positive. Okay, that means that this is positive and the other one is negative, and we have then ig into alpha, and then alpha this way, that's also clockwise, and that's negative. Okay, this is the final equation, and this equation has, we have one equation now, and then we don't have no unknowns, 0 unknown. Okay, you see now we have 3 equations, 4 unknowns. So we need one more. Okay, and that equation will be the kinematic equation. And that kinematic equation will be that A of g x will be alpha cross r, since A is a no-slip. Okay. This one is from chapter 16. Okay. And then let's do that. A of g x is alpha cross r. And then alpha is clockwise negative cross r is, this is point G and this is point A. Then we have r of g this way. This is r, and that is r into dj. And if you take the cross product for this cross product, so k j makes negative I, so that is negative, and negative, that makes alpha r into I. So igx is alpha r. This is by vector. You can also find it by scalar form. How do we do that? So again, so ag is alpha into r, and then alpha is clockwise, so it means that ag must be in positive direction. So let me tell you what. So this is ag, so this is clockwise. This clockwise means that this is the direction of agx. You see, this clockwise, rotation can create a positive acceleration in x direction. That's what it means. Okay, but I generally prefer this, vector product, which gives always true results instead of this intuition as well. Okay, so we have this final equation, and this equation we have one equation and 0 unknown. So total we have 4 equations and 4 unknowns, so we can solve it easily. So let's start from the last one and then replace it back again here, and then solve all the problems. Okay, the first thing is the r is 0.5. That's given in the question, that distance. So agx is alpha by 2. Then we have the equations here. So if I replace the agx back here, then f of f is known, then this one. So let's go that way. Negative f of f plus f cosine 30, f into f is 80, cosine 30 is 0.866, and then into m is, let's check, the m is 60 kg times agx, which is alpha by 2. If you do these calculations, we will get as negative f of f plus 80 times 0.866 0.28, and that will be 30 alpha. Okay. Then comes the second equation, which is n minus w plus f sine 30 is 0. So n minus w is m into g. Okay, m into g is 60 times g. Plus the f sine 30 is 60 times 1/2. That will be 0. From here, n will be 60 times 9.81 minus 3559 newtons. This is very easy, and then we have found it. Then comes the last equation, which is the moment equation, and it says that F times 0.3, which is F was 80. 80 times 0.3, then minus f of f times 0.5 minus f of f times 1/2. That will be negative Ig into alpha, and then Ig will be from the, I forgot it, Ig is from kg squared into the mass. Kg is radius of gyration, it is given as 0.35, and then mass is also given as 60 kg. That will be 0.35 squared times 60 kg. Okay, that will be 60 times 0.35 times 0.35. That is 7.35 kilograms meter squared. Okay, and then we will have the right side as negative 7.35 into alpha. Okay, and then I can combine the first and then third equation. I can solve it easily. It's just a linear equations. Let's do that one more step. So negative f of f plus 69.28 is equal to 30 alpha. From here, multiply both sides by 2. This will cancel out. Negative f of f plus 2 times this one. It will be 24 for the 8. That will be equal to 2 times that one. Negative 14.7 alpha. This is 2 times of this one. Okay. And then we subtract. If you subtract this one from that one, you will get as 21.28. That one plus that one, that will be 44.7 alpha. From here, alpha is 21.28 by 44.7, 0.467 radians per second squared. Okay, and this is what the question asks. What is alpha value? Okay, we have just found it. That's the end.